Okay, so the next question is triplets in binary tree. Uh, this is a binary tree question. Um, this question states that you have been given a binary tree of integers and an integer x. So you have a binary tree and you also have an integer. What you need to do is you have to find all the triplets in this tree such that they form this thing, this relationship, grandparent, parent, child. So like three nodes in this way. So an ancestor, then its child, then its child, or like they can be like um yeah. So this sort of relationship, and and basically there is an integer given. So there is another condition that the sum of these three the sum of the values of these three nodes should be greater than x, and they should be like in this in this sort of relationship. Okay, so let's see. Now the question that you might ask is, what if we have another generation over here? So like suppose we have this and the like imaginary node here, like they have the sum as more than x. Do we consider that also? So the answer is no, because technically this relationship will not be there, because although this and this are like related in the sense that this is an ancestor of this node, but for this to be the parent and this to be grandparent, we have to take the next immediate generation only. So they have to be they'll have to be consecutive in that sense. So we have the example over here, and let's see. So what we will be doing is, let's understand how we can do this problem. So what we essentially need to do is just find three consecutive nodes in the vertical flow such that their sum is like greater than x. So the x in this case is um, 9. So the x in this case is 9. Okay, so let's try this. 1 plus 2 3, and there is nothing else. Also the count is 2, so this will not work. Now let's move to the right side. 1 1 plus 3 4, um, 4 plus 5 9, and 4 plus 6 10. So what this means is this and this, both these are those triplets which will which will satisfy the question. So 1 3 5 and 1 3 6. So let's see how we are going to solve this problem. So this can be solved using either BFS or DFS, but we'll be using DFS in this case. So how we will be solving this? We will keep track of. Let's do it first. So let's discuss how we will be implementing this in the code. So what we will do essentially is this thing. We will start from here, the first the root node, and we will store the grandparent as -1 because it does not have any grandparent. We will store the parent as -1 because it does not have any parent, and the node is this one only. Okay, so we will be doing um we will do, since we have to like move in this way, root to left to right. So we will be doing an in order traversal such that we can also do pre-order traversal in this case, but let's see, let's do in order in this one. So okay, let's do pre-order traversal only. So what we will do is simply um check. So this will be like an if condition that first thing we will be like processing the root. So the first thing that we will do is this processing only. Also, even before this, we can like cover the edge case, which is nothing but like if root does not exist, just return um, a traversal from there. Okay, we do not want to go any further, and the processing would be simple. We will check if the grandparent is not equal to -1, because we do not want that case. We want three, at least three um, consecutive nodes. So we will also check if parent is present or not. If like both of them are present, then we will check the sum. So how will we check? We'll just create the sum such that grandparent plus parent plus roots value, this will be the sum, and we'll just check if the sum is more than x. Then we'll push that trio into the answer vector. This answer vector will be, so the grandparent, parent, and the roots value will be pushed to this answer vector in that case. And after that, we will be, and after that, we will again do the same traversal. Let's say preorder traversal for roots left and then roots right. Um, yeah. So let's see. Okay, let's try to code this now. Okay. So the first thing that we need is an answer vector. So we'll take a vector of vector. Okay. And we will do a pre-order. First of all, we will be sending the root, then x. Then we will be sending the answer vector. And then the parent and grandparent send -1, -1, because the root does not have parent or grandparent. So after this, we will be sending answer, and the pre-order will be like this. First of all, let's add these two, and this will be grandparent, and this will be parent. Or let's do parent and grandparent, whatever, both works actually. uh, Now the first thing that we will do is get rid of the edge case where we have like gone to the reef node. So just return in this case, in that case. Then we'll do processing on root. So if grandparent is not equal to -1 and parent is not equal to -1, what you do is you create a sum, which is nothing but grandparent plus parent plus roots value, and you just compare if sum is more than x or not, and if it is, then just push. Okay, we also need answer vector. This will be passed by reference because we need to keep track of all the pushes. So answer dot pushback, this will take grandparent, then parent, and then roots value, and after pushing, this is done. Okay, and then we'll do call for left and right subtrees. So we can do pre-order such that roots left x answer grandparent, in this case grandparent in this case will become p, and the parent will become the root only. So let's pass this, and again a pre-order on the right. Okay, so this should give me the answer. Okay, test case passed. Submit the code. Okay, code accepted. So the time complexity in this case will be O of n. In the worst case where the when the tree is skewed, and the space complexity will be O of the height of the tree, which um yeah, so fetch which can be O of n in the like extreme cases. Um Yeah, also like the first one will be O of n only because we are like technically traversing all the nodes. So O of n time complexity, and space complexity will be like O of n, the O of h, but like in worst case O of n. Okay, so with that, this question ends over here.